Hello everyone, let us start solving the question number 6 to question number 10 organic chemistry questions from the June 2021 CSIR question paper, okay, CSIR-NET. So, the first question says the major product formed in the following reaction is, so you are having 1,3-dichlorobenzene, you are reacting with HNO3 and H2SO4. So, as we know HNO3 and H2SO4 when they react, they will give the electrophile NO2 plus. Now, NO2 plus is an electrophile. It will look for the most electron rich center. So, very clearly it can be either answer A or answer C. Now, answer C cannot be the right one because you are having nitroate meta to chloro. Now, chloro, you know, though it is ring deactivating, still it is ortho para directing. All halogens are either like this. So, what happens basically, please understand this is this: when you are having a chlorine, it has strong minus I effect. It is a very strong minus I effect, and therefore it is ring deactivating system. What I means is, if you do electrophilic substitution to it, if you react with electrophile, it will react slower than compared to normal benzene, but still it is ortho para directing, because one thing is this bond is weak, this bond is long, weak, because carbon is 2p orbital and chlorine is 3p orbital, but still if you see some amount of resonance does exist, and therefore it is ortho and para directing. So, this ortho gets directed here, activated, I must have shown somewhere, yeah. So, you can see here it gets activated ortho and then para. Similarly, for this chlorine also ortho and para. So, the right answer has to be A, because this nitro is ortho to this chlorine and this is para to this chlorine. Let us go to question number 7. The hypothetical NMR spectrum of proton in H1 C H2. So, proton is being split by deuterium, and we have to look at the proton NMR, right. So, now we have to understand is it is being split by geminal deuterium. Now, how the splitting occurs? It will occur by the formula 2Ni plus 1. Now, the I for deuterium is 1, it is not half. For hydrogen it is half, but for deuterium it is 1. So, it becomes 2 into 1 into 1 plus 1, it becomes 3. So, had it been normal hydrogen, it would have been split into 2, but because it is deuterium, it will be split as triplet. Now, we have to look, two options are there, this and this. So, generally we will think triplet means Pascal's rule, but please understand it will not be Pascal's rule here, because when spin 1 nuclei is there, the pattern is like this: 1, then immediately comes triplet. So, it is 1:1:1. So, the answer is option number C, that is 1:1:1. Next question. This is interesting. The question, the structure that corresponds to the most stable conformation of following compound is. So, you are having this this compound, it is asking which is the most stable conformer. So, if you look at this, beside the oxygen you are having 2 chlorine towards the viewer, and beside this oxygen 2 chlorines are away from the viewer. So, let us look here. If this is the oxygen, we can see that 1 chlorine is away from the viewer, and here another chlorine is also away from the viewer. So, that is all right. Here oxygen also, if you see here, it is towards the viewer, and this is also towards the viewer. Actually, when you see in cyclohexane ring, so we do not look at towards the viewer and away from the viewer, we look away from the plane and below the plane and above the plane. So, it is something like this, something like this. So, you are having this cyclohexane system. So, all the eggshells are like this, see here. So, these are the axial bonds and these are the equatorial bonds, right. These are the equatorial bonds. Now, very clearly you can see here, this hydrogen is above the plane, this chlorine is below the plane. Similarly, because I am comparing these two substituents on the same carbon, here chlorine is above the plane and hydrogen is below the plane. You can see here, of course, chlorine is up, hydrogen down. Similarly, here hydrogen is up, chlorine is down. So, that is what we look. So, what we expect is towards the viewer, in the planar form. In the chair form it will become above the plane, whereas away from the viewer in the planar structure will become below the plane in the chair conformation. So, let us look again here. So, A can be the right answer, because here what you are seeing is, in A what you are seeing is this beside oxygen, we are seeing that beside oxygen 2 chlorines are above the plane, and beside this oxygen 2 chlorines are below the plane. Yeah, towards the viewer that means above the plane, and away from the viewer that means below the plane. So, here also you can see they are below the plane and these two are above the plane. So, this can be one of the option. Whereas, if you look here beside this oxygen, these 2 chlorine are above the plane, whereas these 2 chlorine are also above the plane. Very clearly, if 2 are above the plane, the other 2 has to be below the plane. So, B cannot be the answer, because here all the 4 chlorines are above the plane. Let us look at C. See what happens. Again, 1 chlorine is above the plane, 1 chlorine is below the plane. That is not the possible case, because we are seeing beside the oxygen both are seen either above the plane or either below the plane. So, C also cannot be the answer. Now, D is the option. So, D you are having both chlorine above the plane, you can see here, because 2 hydrogens will be here equatorial below the plane. Similarly, 2 hydrogens will be here below the plane. So, that means clearly 2 hydrogens are above the plane, and similarly here if you look, 2 hydrogens are there. So, these hydrogens are above the plane compared to chlorine, right. Similarly, this hydrogen is also above the plane. So, these 2 chlorines are below the plane. So, very clearly you are having beside 2 oxygen 2 chlorines above the plane and 2 chlorines below the plane. So, now we have to find out which is the right one, A or D. A or D, that is what we have to find out. B and C are clearly ruled out. So, if we think from a stereochemistry point of view, we know that substituents are not favored in axial position. Equatorial position they are favored because they face what is called as flagpole interaction, 1,3 diaxial interaction. This is what we think that it might be facing problem. So, this is what will be better, but that is not the right thing when electronegative atoms are attached. There is something called as anomeric effect. So, what is anomeric effect is, please understand. So, when you are having this chlorine, so these are weak bonds. So, they have bonding molecular orbital, then of course, they will also have anti-bonding molecular orbital which is vacant. Now, this if it is in parallel with the lone pair, this lone pair pumps electron to this anti-bonding molecular orbital and stabilizes it. So, only when it is in axial position this possibility anomeric effect, anomeric stabilization is possible, not when it is in equatorial position. So, rather the 2 chlorines will be in axial position rather than the equatorial position. So, D will be the right answer. Moving on to the next question, question number 9. The molecular orbital involved in interaction of oxime shown below with a base. So, very clearly base will pick up the most acidic proton. Which is acidic proton? The proton which is attached to most electronegative atom. So, clearly this hydrogen. So, what is this hydrogen? So, you can see any orbital there has 2 bonds. What is bonding molecular orbital, anti-bonding molecular orbital. Bonding is with joins and anti-bonding is where the other nucleophile will attack. You know, whenever bonding occurs, always nucleophile comes with its HOMO, it interacts with the LUMO of electrophile. So, here it is like electrophile. So, it goes and pumps electron here and takes away this proton. So, of course, it will be answer will be sigma star of OH. So, sigma star of OH, A will be the answer. Last question for this video. The reaction that is expected to show primary kinetic isotope effect. So, primary kinetic isotope effect means where I am changing the isotope. So, here it is talking about CH. So, if I made instead of H put deuterium, if breaking of that bond occurs in the rate determining step, then rate is greatly influenced by change of deuterium. So, we have to find out if this CH bond breaking occurs in rate determining step or not. So, let us look at each reaction one by one. So, we will get it. So, let us look at the first reaction. First reaction of course is Friedel-Crafts. It is not Friedel-Crafts, yeah, it is a halogenation on benzene. So, electrophilic substitution reaction where hydrogen is being replaced by bromine. So first of course bromine comes and attacks here, you get this, and then this goes and attacks here to get a unstable. So from stable species you are making unstable. So this has to be the slowest rate determining step. In the rate determining step, H is not touched at all. Only in the next step, when it is becoming from unstable to stable, this proton is being removed. So this has to be fast, because from unstable is becoming stable. So it cannot show primary kinetic isotope effect, right? Second one is sigmatropic 3 sigmatropic arrangement. So this comes here, this comes here, and this comes here, you are getting this. So what happens in the first step? You get this. So what happens in the first step? From a stable species you are getting unstable species, right? Because it was aromatic system, now you have made it non-aromatic system, but hydrogen not touched at all. So this has to be slowest step. Second step is from unstable, from the ketone is again becoming aromatic. So this has to be fast. So this cannot be slowest step, and here is where hydrogen loss. So this cannot be rate determining step. So this also cannot be cannot show primary kinetic isotope effect. Third one, basically they showed one ketone and they said bromination is occurring. So first step is you are tautomerizing from stable ketone to unstable enol. So this has to be slower step, right? It has to be rate determining step, and in this rate determining step you can see that hydrogen is lost, and then second step this comes down, picks up bromine, and you get this. So of course this will be the answer, C has to be the answer. But let us also look at D. So D, what is happening is you are from the alcohol you are making alkene. So first step is protonation, and then this leaves. So this is the tough part. This is the tough part because you are making unstable species, and then second step of course will be fast. So D cannot be answer. Answer is option C. So that's it for today. Thank you very much.